Hello everyone, thanks for having me. I'm Oben, a daily TDC commuter and also coder. And today I'm going to show you how I made a TDC tracking website that requires less data than taking a picture with your phone and emailing it to someone. So I take the bus to and from school basically every day, and I'm sure that many of you have also used the TDC a lot as well. And I'm sure we know that all these routes, they have schedules that they're supposed to follow, but they don't actually always follow these schedules. Fortunately for us, though, they have these nice polls at basically every stop, and you can text the numbers on them to see estimates for when buses are going to arrive. Unfortunately, though, they're not always accurate either. There's a route that I take fairly regularly where the bus kind of usually gets, it says stuck at like 2 minutes, but for like 10 minutes while the bus is in a station. So I really wanted to find a way to kind of figure out where my buses are and know when they're going to arrive. So it turns out there's actually a lot of bus mappers that are out there right now, and maybe names like Transit, City Mapper, Move It, or of course Google Maps might be familiar to you. These all provide services for tracking when buses are going to arrive, maybe like locations or more information about routes or other stuff like that. Unfortunately, I have a pretty limited data plan, and a lot of these have a lot of features and stuff that I don't actually need and that use up more data than I can afford to use regularly. So I was kind of thinking, like, I do want to see these locations, but I don't have these options. So there are probably better options than this, but I decided to kind of make my own tool for doing this. I was just learning how to host static sites using GitHub Pages and how to use APIs to get data from services. So I wondered if I could combine both of those newfound skills and make something actually useful. So basically, I needed bus locations, and the first thing I found for that was this now retired API hosted on UMOIQ called the TDC NextBus JSON/XML feed. And this was a super accessible feed that you just send a request to, and you can get a whole list of all the vehicles on the TDC network with information like location, direction, and bus type. And you could also get route geometry, which I would later use. So with this covered, I tried to start to identify some of the main data eaters of all the TDC services that were out there now. The first one was the background map. From what I'm aware of, basically all of the services right now use something called map tiles. And essentially, this is just the idea of splitting up the viewport into a grid and then only downloading images associated with the visible squares. And this can be pretty efficient because you're only actually downloading the data for the images that you're actually showing. But it's important to consider that for every layer that you go in, it divides up those squares more. So then at the innermost layer, there might be like thousands and thousands of different images that could be downloaded. And that's just a lot of data that I really wanted to avoid. A lot of the services do allow you to just pre-download the entire map as a whole, but I really wanted to avoid that much data in the first place. The second mobile data eater was images, and I'm including ads in this because some of the services I was looking at did actually embed ads in their services. Obviously, the simple solution is just to not include them. But in terms of images, if I really need to include them, I can use really optimized formats like scalable vector graphics. And finally, there were heavy libraries and frameworks. This definitely is this would take a lot less data compared to some of the other ones like images. But I really wanted to avoid using libraries that would like double the size of the site, even though I didn't really absolutely depend on them. In the end, I actually decided to not use any front-end libraries or frameworks, and this probably was worse in the end. Maybe now I'd use something like Svelte, which is like a really lightweight front-end framework that would have helped me a lot, but oh well. So with the vehicle locations down, I tried to look for ways to display the map in a more data-friendly format. I decided to kind of go for a different option, which is actually just taking the raw road data itself. And I found that on the Toronto Open Data Portal. And yeah, I'm sure it's been mentioned here a lot. There's even like a Toronto Open Data Cake, or Toronto Data Cake. But yeah, I was able to find that Toronto Centerline data set. And it has a whole bunch of information about Toronto, like roadways and walkways and railways and waterways and all sorts of things. So this is perfect. It was 93 megabytes though, so I needed to bring that down a bunch. And the first thing I did was just take out the road geometry, which it isn't in a GeoJSON format, which when you take out the road geometry, it's just a bunch of straight line road segments, which I then combined and turned into a coordinate difference array. And then using just like basic compression, gzip compression, I was able to get all the road data of Toronto down to about 700 kilobytes. This was omitting certain things like road names of very small roads, but I felt like that was kind of a worthwhile change just because they took a lot of data and I don't think it was completely necessary to have. So it was great. I was able to combine the vehicle location API and also this Toronto centerline data and make a website that showed bus locations. And for a prototype, it was very good. It was about 800 kilobytes to load the site, and then it would cache most of that anyways, so that later loads of the site would only be about 10 kilobytes. And then while showing bus locations, it would take about 3 kilobytes per minute to track. There were some limitations though. My road algorithm wasn't perfect. Sometimes it would connect the roads wrong. And my name algorithm was even worse because I had to kind of manually make the algorithm myself. And the only really experience I had with making websites was just some like basic HTML and JavaScript. So it also wasn't very user-friendly either. Something in me though really wanted to kind of just recode the entire site itself, addressing all these issues, but I did need a good reason to do it. Over the summer, though, I had a lot more time and a lot of these tools and services I wanted to learn, like TypeScript, WebGL, Docker, Google Cloud Run, and Cloudflare. So I wondered if I can kind of combine that with the project I was working on before and remake Busferret. So the first thing I did was look at my road algorithm from before, and I was able to find ways to optimize it and actually fix up weird road connections. So I was able to bring the data down even more. One decision I chose to make was also pre-downloading all the routes all the TDC routes, which I was able to find on the retired database I mentioned earlier. And this did increase the size of the site overall, but I think this was a really worthwhile change so that you can kind of download the data in advance. And then later on, when you're opening a new route, it won't actually take any more data to show the path. I also had to try to find a replacement for the old vehicle location API because it was being retired. And fortunately, yeah, on the Toronto Open Data Portal, this was the kind of replacement for it. It uses a GTFS format, which is sort of the more modern version that transport networks use to show live data or static data for their networks. In this case, there's the GTFS real-time data set. And kind of like before, you can make a request to their API, and you can get a bunch of information about all the buses on the network, like this is kind of the same thing as before, like direction, location, bus type. And then you also get a trip ID, which you can link to a kind of more a static database that they also have. And this could allow you to get information like tag name and also route geometry. So with this, I now combines these two kind of refined parts of the website, and I remade it. And it honestly kind of has the same data usage as before, but there was a lot more features, like I was able to incorporate alerts, also from the, I think it's the GTFS API as well, and other features like seeing nearby routes and a lot more configurable settings. Yeah, the first load is about 800 kilobytes, the subsequent loads are about 17 kilobytes, and I kind of had to find a compromise between using a very small amount of data and also kind of making it more user-friendly. So I did decide to update, to increase the amount of updates it does to update vehicle locations while tracking to 6 kilobytes per minute, which is still a very small amount, and I'll go over data comparisons later. As it stands now, though, there are still limitations to Busferret. It is limited to just TDC buses and streetcars, and I do know that there is like a Metrolinx API that I could look at later, which would allow me to show like Go bus locations as well, but that's not really in the plans. And also, it does kind of look cluttered sometimes, because I don't really know how to design a website to make it super user-friendly, but I was able to come up with something that did work. I do want to go over some kind of very quick data usage comparisons of Busferret compared to other services that are out there. I'm comparing Busferret to Citymapper, Transit, and Google Maps, which I think are some of the more used services. So just kind of loading the site or app itself. This was using through Google Play. I got Citymapper, Transit, and Google Maps. And Busferret, it's just a website, so this was loading the website itself. City Mapper is the second least amount of data used, and it was still about 40 times more data than Busferret. And also, I think it should take into consideration that Busferret, this also includes all the data of all the roads in Toronto and all the routes on the TDC, but these data amounts don't. I don't really know if this is actually a super useful metric, though, because most of the time you're downloading the app over Wi-Fi or something, and then later when you go out, then you're actually using it. But just to open the app itself, it does have to kind of get data from the servers just to load the basic information that it needs for you. And even then, so this is just opening the app itself later. Google Maps takes the second least amount of data, but it's still about 4 times more than Busferret. And finally, this was actually using it on an active 10-minute ride. So this is having the apps open and kind of moving around a tiny amount and like clicking buses, maybe. And here, Busferret was about 7 times less than Google Maps, which was the second one. I really hope that by making a very data-efficient bus tracker, I'm kind of giving a new option for people who maybe wouldn't have had access to this information before due to data reasons. And also, by making a really kind of minimal tracker, I'm giving another option for people who just take the same route every single day, regardless of the situation, and just want to know a little bit more about their buses. Thank you.
That was amazing. I've personally used your product. I think it's pretty impressive. Online participants, please drop I in your chat box. Alex will call you out for. So now we move to the Q&A session. Yeah, please type I in the chat box. Alex will call you out. And in-person participants, do we have any questions?
Hey, awesome presentation. I don't know if this is on or not. Is that on? Yeah, okay, great. Oh, okay, great, thanks. 2 questions for you. One, GTFS, it's Google Transit something standard.
Yeah.
Do you think the fact that like Google defined a standard that's now like part of our civic infrastructure, like is that, do you have any thoughts about that? And I wonder, the fact that Google Maps uses so much more data, how much of that do you think is, their ad tech or, surveillance tech in their stack? Thanks.
Yeah, so just for the first one, I think it's a good sign that open data is using it, because like we're definitely progressing and using more modern infrastructure. Yeah, that's good. In terms of Google Maps, I'm pretty sure a lot of it is, yeah, like tracking stuff or the other things you're mentioning. Also, it could be just like the map itself, because when I was doing that test, I didn't actually pre-download the map. I was just like scrolling around, so it could be part of loading the map tiles as well.
Right. Cool. Thanks.
The million-dollar question, of course, is were you able to get better data about where the bus actually is?
Oh, I mean, yeah, I mean, it definitely works. Like, I use it very often, and it seems to be very accurate whenever I use it. So, yeah, it was successful.
I really like your website, been daily using it. 2 questions. First one is, do you have like any feature that you want to work on for the project? And second is, do you consider doing open source with this?
So in terms of like new features that I'm planning on adding,
Just anything.
I mean, I guess something I could include eventually is like introducing other cities into it as well. I don't really have anything planned or set in stone yet, though. And sorry, what was the other question?
Open source, do you?
Oh, yes.
Open sourcing this, or do you want to keep it private?
I mean, I definitely I could open source. I'm not like the way that I've coded it. I don't think it's super like accessible to other people. I think I would definitely consider looking into that in the future, though.
Thank you. Do we have any questions online, Alex?
Yes, we do have a question from Dan online. I also just very quickly wanted to contribute that GTFS has not been owned by Google since 2019. It's actually owned and operated by a Montreal-based not-for-profit. Please go ahead, Dan.
Hi, great presentation. We have a project called Open Transit that was our first thing when we launched our org here we were formerly Code for Vegas, which was part of Code for America. So yeah, all that. Anyway, so I ride the bus also here in Vegas. They've had a GTFS portal for developers for a while. I'm curious to know I have two questions in that context. One, do you think maps are essential for an application like this, for a daily bus driver, someone who takes one route and all that? Do you think maps actually add value, or do they add confusion and whatnot? And I can follow up with some specific context if you want.
Yeah, sure. I guess I'll answer first. Background maps, I think it's useful to know where the routes you're looking at are. If you're more familiar with the routes, I guess you don't need it, but I think they're really important.
Right. So one of the considerations, because when I ride on the bus, I talk to everybody, kind of get their feedback. And the transit app, which you're familiar with, they are, and I think is a transit app is based in Montreal, so I'm assuming they're affiliated with GTFS at this point. I was sitting on a bus one day with someone who was vision impaired, not legally blind, but probably legally blind, but definitely couldn't see 100%. And I asked him, because they changed schedules. And I said, "Oh, he was like, "Oh, I almost missed the bus." I said, "Yeah, they had a little notification on the app." He goes, "I can't see the app because the app is not really created for people with vision impairments or accessibility issues." So to me, it makes sense to make a version of this where he doesn't have to try to find. I'm not complaining, and I'm not, but I'm just saying the context is that I wonder if accessibility could be addressed with super large route numbers, don't focus on maps and moving icons and little tiny text versus very large text, high contrast, all the usual stuff. So that's something I've actually been looking at a little bit more lately. So what do you, in that context, what would you think? Since you've done it, you've done something new. So
yeah, I mean, I didn't really consider that perspective before.
I don't think Transit App did either.
Yeah.
And who's going to ride the bus? People with vision impairments? Nah.
I mean, you could. Yeah. I could.
And I have one more question too. Can I ask one more question?
We'll take some questions in person, and if we have time, we'll move back to you. Thank you.
Okay.
Congrats on the website. I used it yesterday. It's pretty neat. Does definitely achieves what it seems like you set out to do. Really cool to see the data usage differences too. I was curious if you had any familiarity with, before you started this project, on any web mapping. As someone who studied a little GIS in undergrad, seeing you tackle something that definitely involves obviously using GeoJSON and having to figure out how exactly center lines works and nodes becomes lines and then polygons. And how was that learning experience? Did you already have that education, or just figured it out as you went?
Looked at the data sets and then kind of had to figure out how they worked. Especially with the GTFS, that was kind of difficult too, because I didn't really actually look at much documentation. I kind of just went through it, and then eventually it worked. Thanks.
Thank you for the presentation, and this is awesome work. I guess two related questions. One is, what could the Open Data website have done better to support you as you were making this? And two, what do you think is the biggest blocker / potential point of support for this project for you now?
Okay, so I guess in terms of what's available in Open Data, I kind of did choose to kind of not really look online to see how things worked out. Maybe that would be useful for other people that are kind of working on the same project, for maybe resources to learn how to actually use the data itself. I don't really know how much of that is on there right now, but like for me, when I was doing it, I kind of chose not to look for that. So I don't know if it would have helped me, but it definitely could help other people. In terms of limitations now, I'm not really developing it as much anymore. I think just the way that I've kind of coded it, I wasn't really meant to be super long term. It was kind of like a small project. So I'm kind of running into difficulties adding more new features now.
Why a ferret?
Because ferrets, they like fetching things. They like getting things, so it's like you're getting the bus locations.
Well, I assumed that you were gonna continue developing this, so I was gonna ask if you thought about like taking rider feedback, especially for like late buses, missed bus stops, and things like, "Hey, they drove right by me." This is a huge problem in Vegas, so it's something I've thought about. Just wondering if like real time engagement with bus riders in the context of your app is something that you thought of, but that's only if you're continuing development.